You know what, chicken wing? You know, some people think you're funny. A lot of people think that you're funny. I, on the other hand, grown up a little bit recently. You know what? Now I just see you as who you are. You're a foul mouth, slight, morbidly obese, you cuss too much, you smoke too many cigarettes, you look at all of these fat girls and you make fun of them for their medical You know what? You're just messed up in the head. You're messed up in the head. You're a fucking pig, all right? You're a pig, chicken wing. What do you have to say for yourself? You know what? You're messed up. I'm out of here.
Welcome, everybody.
Welcome again to episode number 25, a quarter of 100.
A quarter of 100. And we have like over 40 total, maybe 45. I don't know. We have a lot of episodes out
There's
there.
a lot in there. Browse the catalog. Check some things out. There's some cool things there.
This is number 25 of our big main episodes.
Yep.
And today we're going to be completing the electric series. We had Large Electrics Part 1, where we gave a big overview of everything electric, kind of. Then Large Electrics Part 2, where
mainly
we talked about speed controllers more than anything, really.
Yep.
And this is Part 3.
Everything else.
Everything else. So what's everything else? Motors.
Batteries. Chargers. Connectors. Soldering.
We're going to talk about soldering a little bit.
And gearing.
Gearing, yeah. 6
main topics today. This is going to be a really, really, really technical episode.
Yeah, it's one of those boring ones, I think.
Well, hopefully not. Hopefully we'll try to make it exciting.
Yeah.
And mess up our lines and fart and all sorts of shit. It should be cool, though. There's really so much to talk about. I mean, motors have come so far.
Yeah, I agree. Batteries and the charging. And,
I
get questions about charging all the time. And I get questions about, what connectors do we use and why? And a lot of people trying to overgear the crap out of their machines and everything gets hot. So we're going to talk about gearing. There's a lot of cool things we're going to talk about. So
it should be good. And once again, keep submitting your comments and stuff.
Yeah, please.
We appreciate that. We get a lot of our episode ideas off of the comments and whatnot.
Yeah.
And
so let's hit it.
Let's go. 25.
Number 25. Okay, guys, we're going to start the episode by talking about motors. Motors is really a component that's part of an electric helicopter that doesn't really have a lot of things to look for. It's not like a speed controller where there's so many different features to look at and reliability and make sure that it's not going to catch fire and make sure that it's going to perform and governor and all this. Motors are a lot simpler. There isn't so many things to look for, but yet there's a few things to talk about. First, let's talk about the types of electric motors. Of course, you have the in-runner motor. The in-runner simply means that the whole construction of the motor, all the moving parts are inside the main motor can. So when the shaft rotates, everything that is turning and rotating in the motor is rotating inside this can. So if you have, for example, a canopy that's touching up against the top of the can, nothing's going to get hurt because nothing's really rotating other than the shaft. And the next type of motor is the outrunner motor. Scorpion is being the most popular motor out there, I believe. For the most part, they have some in-runners, but most of them are outrunners. And an outrunner motor, basically the outside of the case, the outside of the can turns along with the shaft. Main differences between the two, hard to tell, mostly construction. Some people argue and say that the outrunner has more torque. Some people say that the in-runner runs more smoothly, I guess, than an outrunner. To me, really, I don't feel much of a difference. I've flown them both, and I really can't tell whether one is better than the other. For the most part, it seems like the end runner is a little bit smoother, but sometimes the end runners run a little hotter. That I have seen. The outrunners run just a little bit cooler. Other than that, just make your pick and just choose one that you think you'll like the best. No difference. Don't sweat it, whether it is an end runner or an outrunner. This one right here, again, is made by NEU in collaboration with KDE. You also have the Scorpion, and you have this new brand called Quantum. I've been flying these. They're doing really, really well. So that's basically the two types, end runners or outrunners. The next thing about a motor is kV. kV means how many times the motor turns, how many revolutions per volt. So, for example, in this case with this Quantum motor, it says 560 kV. That means that for every volt of power that you feed to this motor is going to turn 560 times. So if you do the math, say for example you have a 10S setup, that's 42 volts maximum. If you multiply 42 times 560, you get the RPM of the motor. So I've seen people that choose their own kV for their particular application, and of course there's other things you need to look for, like gearing, and we're going to talk about gearing towards the end of the episode. But kV is important. Try to go with the right kV so that you don't have to run into issues when trying to find the proper gearing. If you get a kV that's too high, you might not find the right gear ratio for that kV. So look at what the manufacturer of the particular helicopter you're trying to fly recommends for kV of a motor and go with that. Generally on 700 class electric helicopters, you want something in between 450 and 530 kV or so. So that's an important consideration. The next thing is the efficiency and the power. Generally, the more power that you get out of a motor, generally, and this is not always the case, the less efficiency you'll have, the less efficient the motor will be. In some instances, some motors such as Quantum and Scorpion, they find a good balance between power and efficiency. It's not ridiculously powerful and it's not too inefficient. So they find a good balance. That's an important thing. Efficiency always also, of course, comes from the way you gear your helicopter and the amount of cells you're running in your application. But for the most part, you want to make sure that you have a motor that has a good level of efficiency. 90% plus efficiency is what you want out of a motor for the most part. Another thing that is also important to know is your pole count. Even though you might really not do much with it, some speed controllers, such as for example Castle controllers, ICE, when you run the set RPM mode for the governor, the controller needs to know how many poles your motor has in order to calculate the head speed. So it's just something to keep in mind when it comes to choosing your motor. Quality, of course, well, quality is pretty good on all of them nowadays. I mean, these motors are really, really good. The Scorpions are good. The NEUs are good. Even Align is making motors that are pretty good, decent quality these days. So that's really not a big factor anymore. But it's obviously something to keep in mind when you buy a motor. And then the size. Try to go with the size that is suitable for your helicopter. Usually the first numbers in the motor, if you see this Quantum says 41, 25, 560, the first numbers mean the size of the motor. 41 meaning the width of the can and 25 the height of the can. If you're going to go with the 600 class machine, pick something in the 40 to 41 first two digits can size. For example, like a 40, 35, 560 Scorpion motor will be great for a 600 class machine. If you're going with a 700 class machine, pick something in the sort of 45 can size, like a 45, 25, 45, 30 can size. Try not to put something this big on a 600 or something that small on a 700, depending on your flying style. Just make sure you get the proper size motor for your application. And then one thing that I'm almost forgetting is the counterbearing. A lot of motors that you guys get have a short shaft, and then you have absolutely no way to put a counterbearing on the other side of the motor. That not only leads to premature gear wear or gear stripping on your helicopter, but it leads to premature bearing failure on the motor. So if you have a helicopter that can accept a counterbearing, like for example a T-Rex 700 or a Whiplash miniature aircraft or any of those models, make sure you order the motor with the long shaft. That way the shaft will reach the counterbearing, and what that does is that holds the shaft at the top. And keeps the load, removes some of the sideway loads that will over time deteriorate or ruin your bearing in the motor. So it'll just make your bearing last longer. Finally, there's a myth I've heard some people talk about where it says, well, I don't know if you guys noticed, some motors have a lot of cogging. And some people relate or think that the cogging is due to the fact that the motor has more power. This couldn't be farther away from the truth. Cogging has nothing to do with power. I've flown motors that have like no cogging, that turn very easily and have crazy power. And I've flown motors that have a lot of cogging that takes a lot of effort to turn them when you have them in your hand, and they are not as powerful. So the cogging is just a feature of how the motor is constructed. The type of magnets they're using, the number of poles and all these things, it has nothing to do with power. So that sums it up for motors. Now we're going to move on to the next segment.
Hello everybody, welcome to Bert's Couch. I'm doing this little segment on the couch because today is a sitting on the couch type of day. Easy now. So next we're going to be talking about batteries. Here I've got 3 different types of batteries, and I don't know, I think batteries are mainly the reason why the electrics have become so popular and have really taken off. Maybe a few years ago, maybe, I don't know, 6, 7 years ago, the LiPos weren't at all what they are today. Today we've got discharge rates of 45C, 60C, I've heard 90C, just outrageous things. Back then we had maybe 25C and 10C, 15, just very, very poor. The batteries would always puff. The manufacturing exactly one of the best, and they were super expensive. I mean, it would be maybe $600 to fly your 600 or 700 class helicopter one time. Now that the batteries have become a lot more affordable, they're safer, they're putting out tons and tons and tons of power. Electrics have really, really, really taken off simply because of these guys. So first thing I want to talk about is just the number of cells. So here I'm holding a battery. This is for my Gaui X5. It's a 4200 milliamp 6S pack. So the first thing you want to look at when it comes to batteries in your helicopter is the number of cells. According to Mr. Ohm and Ohm's law, voltage equals current times resistance. I learned that from school somewhere. So that means that the higher the voltage, the less resistance you have. So if you're looking at like a 450 class helicopter, for instance, right? You see a lot of guys, like our buddy Chicken Wing prefers to fly his on 6S. You're bumping up the voltage, you're getting a lot less resistance, and everything should run smoother. It should run cooler. Your engine should work, your motor should work a little better, your speed controller should work a little better. So that's why, for instance, with like a 700 class helicopter, we prefer 10 or 12S instead of 10S. Just the higher amount of voltage we can cram into it, the better. So first of all, we're going to look at voltage. That's most important. Next thing is the milliamp. So this is a 4200 milliamp pack, so milliamp hour pack. So let's say, for instance, we had a 5000 milliamp hour pack. So for instance, that's 5 amps. If I want to discharge this thing at 50 amps, for instance, right? So 50 amp hour pack. So that means I could discharge it in 6 minutes, just current. So this kind of helps you base off your math, because you can look at your discharge rate, your C discharge rate, and that can help you. Okay, so if I'm drawing 200 amps, my flight time's going to go significantly down to 2-3 minutes sort of deal. So that MAH, milliamp hour pack, you can do your math and figure that sort of thing out. So that leads us to our next thing, the discharge rate. This pack that I have here is a 45C discharge rate. I've also got a generic brand. I don't know what this is. It doesn't say the discharge rate on it. And then we've got one of Bert's Pulse packs. This is a 45C discharge rate as well. Well, what does that have to do with? Well, the C rating just shows how much energy the pack can give. So for instance, if we have a 5000 milliamp pack, so a 5 amp pack, and it's 45C, that means that the overall peak momentary discharge of the pack is 45 times 5000. So that gives you so it's at like 250 amps, a little bit shy of that. And that's just your burst. It can't maintain that, but that's just your burst. So is a higher C pack a better pack? Not necessarily. But you also want something that's not going to have to work too hard. So for instance, in flying my helicopter, a 45C pack, 60C pack, those are really good numbers. If I'm flying my 700 class helicopter and I'm using maybe a 25C pack, that's not going to be able to give me the amount of amperage and the amount of burst that I can handle. So I kind of want to keep that in mind. If I'm running a receiver pack, sure, 15 amp, 20 amp, or sorry, 15C, 20C, 25C receiver pack, sure, that's fine because it's only handling maybe 10 amps or so. So that's really just about it. So batteries, what makes them great? Here we've got 3 different types. For instance, this Hyperion pack sells for, I believe it's close to $200. This Pulse pack, which is very similar, sells for maybe about $140, $150, you know, that sort of range. So why are the batteries so different in pricing? You know, I can get a Turnigy pack for half the price of a Thunder Power. Well, here's the honest truth. Ready? This is why we're on the couch. All of the LiPos out there are made by the same 3 people in China. All of them. The cells are the same. The cell that's in your iPhone, well, maybe, I don't know, they do secret stuff. But all the cells out there are the same. The biggest thing, if you want to refer even back to our first electrics episode when we interviewed Jason Merkel from Thunder Power, he even told us, the biggest difference is how they manufacture the cells, the quality of the components that they do, the matching of their internal resistance and the matching of the cells, and just how well they put the pack together. So for instance, if you look at a Thunder Power or Hyperion pack, they're very expensive because they're very, very, very adamant about making sure those components and the quality are very, very high, which is probably why you'll see less problems with a higher price pack just because they put so much time and effort into it. Whereas the cheaper packs, maybe such as Turnigy or Zippy or Rhino or that sort of thing, I don't want to say they just hastily put them together, but I'm sure the quality of the components are not as good in those type of packs. So that's the biggest thing. So you want to look at what you can afford, what's going to be the best. Is a more expensive pack going to be better for you? I don't know. If you crash and destroy it, no, you spend more money. But it might last for you better in the long run. So that's really up to you. Bert and I both prefer to run nice, good quality packs that aren't going to break the bank, but we also want to make sure that they're not just going to explode in our hand. I've had that happen before. That's really bad. You don't want that. So with talking about a pack too, we'll talk about puffing. So right now this pack, for instance, this is just a no-name brand we got for testing. If I squeeze it, it's very hard, which is fine. When a battery starts to puff, what will happen is the bindings in between the cells actually kind of starts to split a little bit, and the cells will just puff and it'll be squishy. Now, is that a bad thing? Not necessarily, because some of the packs, you know, even my Hyperions, I've got some packs with a lot of flights on them, very nice packs, they'll puff. And do I want to throw it away? No, puffing isn't exactly a bad thing. Some causes of puffing is over discharge and just pushing them really hard, and not overcharging, but just really high temperature, just abusing your packs will do that. So if it's puffing, just keep an eye on it. Now you want to do the smell test if you think it's bad. If you ever think a battery's bad after you crash, just smell it. This smells like a battery, I don't know. It smells like plastic. What you don't want to smell is like a very sugary, sort of sweet smell. Kind of smell, it's a very distinct cell. You'll know what we're talking about when it opens. When you smell that, it's very bad because that means the cell is open and it's very dangerous. So you have to do one of 2 things. Number 1, dispose of it. If you're out at a very large site where they don't mind if you dispose the batteries, hit it with an axe, shoot it with a gun, stab it with a screwdriver, throw it off of a bridge. Just do something to it. Don't put it in your car. Don't risk your family's life. Don't risk your life. Don't be an idiot for $50. Stab it, kill it, make it go away. Second thing you can do is a little bit less exciting. Put it in a big bucket of salt water. Leave it in there for a week or 2, and the ionization will just kill it and make the pack completely neutral. And one more thing with batteries, I almost forgot. How to make your batteries last. The most important thing with flying your batteries to make a good or bad battery last is be careful of how much you discharge it. At most you want to discharge 85, at most 90% of your battery. We used to say 80, we've kind of pushed it to 85% of your pack. So if it's a 1000 milliamp pack, check after you're done flying it. Make sure you've only put in 850 milliamps. Anything more, you've got to reduce your flight time. Set your timer a little bit back. Give yourself some time for an auto, whatever. That'll just over discharge the cells, and that'll make them want to puff, and that'll make them, honestly, they get less powerful, and you lose a lot of performance. Your IR, your cell's internal resistance goes up. You can physically check that on your charger if it offers it. Just make sure that you don't over discharge it. The other thing is charging. So a lot of these cells, for instance, this pack, this 45C pack says it can charge at 6C. So I can charge at 6 times 4.2 amps. So I can charge at 24 amps, 25 amps safely. Now, if I do that a lot, the cell won't last. When I'm at the field, yeah, I'll charge 4, 5C easily. But when I'm at home, set it at 1C. Just give your batteries a little bit of a break. You spend a lot of money on these packs. You work hard at work. You just want to play. Make your batteries last. Just treat them with a little bit of respect. So that's batteries. On to our next segment.
Okay guys, for our next segment, we're going to talk about chargers and charging. We're not going to cover brands or any of that stuff. We're not here to endorse anybody, but it's important to just talk a little bit about chargers, how to charge, some common mistakes I see people make and stuff like that. These are some awesome cases right here. Buddy Jay Vanderloos, I think his last name. He goes by SNJ Bert on Heli Freak. He made these for us. He made mine a long time ago. I was at the time flying another brand. He made Bobby's recently. We're going to show you this here in a second. But let's talk first a little bit about a few things that are important. First thing, when you buy a charger, make sure you're buying a charger that has the ability to charge at the rate you want to charge at, and that has the ability to charge the number of cells you have. I see people flying, for example, Logo 600 with a 10S stick pack. They buy a charger that can only do 6S. Well, now you're in trouble. So a lot of these guys end up splitting the packs, and it just becomes a nightmare. Just make sure you buy a charger that can charge the number of cells you have and that has the capacity, the current, the power that you need. Another thing that you got to keep in mind when buying a charger is what power supply you're going to use with that charger. There's a lot of different power supplies out on the market, a lot of them. Some of them just don't have the juice that you need to charge. If you have a 1000 watt charger, you need to make sure, if you want to use the charger to its maximum capabilities, you want to make sure that you have a 1000 watt power supply or its equivalent, or maybe two 500 watt power supplies in series, or something that will allow you to at least, maybe even 700 watt power supply, something that will allow you to use most of the charger's capability. Having a 1000 watt charger with a 100 watt power supply is just stupid. You're wasting your money on a charger. Just buy a cheap 100 watt charger and be over with it, because you're just literally, again, wasting your time. You have all this capacity you can't use. So that's important, power supplies. I have some old power supplies right here. These were made by Radio Shack. It's only 25 amps. It's really not enough for most of today's applications, but I still use it occasionally for receiver packs and stuff like that. iCharger is making a small power supply. I'm going to show it to you. It's also made by Volts, as a co-brand. It's a really good power supply. It can handle, I believe, 350 watts or something like that. So you can double it up, make 700 watts. Good system. Of course, you can use the good old servers, rack type servers that are used for industrial data centers applications, that some of them can put 300, 400, 500 watts. You can run them in series and create a lot more power. I believe that's what Bobby has here. So make sure you have the good power supply. The importance of a good charger. All chargers nowadays are good. Let's go ahead and open this thing up. This is Bobby's case. Bobby's got, wow, this is very nice. He's got a professional balanced charger, this charger right here. I don't know what that is, but it looks cool. And he has the Hyperion one right here. And under this, again, this is courtesy of our buddy Jay. What he does is he just takes this cord, he plugs it into the site, like his site has a port just like that one, plugs it in, and then plugs it into the wall. Power supplies boot up, and he's good to go. So it's a really cool deal. He's got some server sort of industrial power supplies, two of them. They're wired in series, so he's getting 24 volts, which helps the charger charge at a higher rate, and it's capable of charging at the full maximum capacity, or I guess power, that the charger can provide. But the important thing again here is when you pick a charger. Hyperion, great charger. iCharger, to me, great charger. Also Volts, the same thing. The important thing is when you pick a charger is, number one, again, I'm backtracking here. Make sure it can handle the cells you have. Make sure it can handle the current you want. Also, make sure it has a really good balancing circuit. I see some, for example, I don't want to really bash Hyperion. I love this charger. I think it's a great charger. But Hyperion's balance really, really slow. Like when it gets to the end of the charge, it seems like it takes forever just to get the last 50 or 100 milliamps into the pack. It's like it's balancing and all this. Some chargers have like a really powerful balancing circuitry. I think the iCharger, which is the same as the Volts, has got like a 300 plus milliamp balancing circuitry. So when it gets to the last part of the charge, it just peaks like super fast. So keep that in mind. Nothing wrong with Hyperion, great charger, but that's something to just keep in mind. Let's open this one up. This one is the iCharger. It's co-branded 2 volts, but it's a similar deal. As you can see here, it's got the 2 volts power supplies. They're the same as the iCharger power supplies. These power supplies, again, they're capable of, I believe, 300 or 350 watts of output. So when you wire them in series like I have here, you're doubling your throughput. You're doubling the amount of voltage that you're supplying, and you're doubling the amount of total watts that you can supply. So it's a pretty cool thing. If you think about it, these things are 15 volts. So when both of them are running in series, you have a total of 30 volts. Input voltage. When you pick your charger, make sure that you can handle the input voltage. If you have 2 power supplies that are putting out together, 15 amp each in series, you have 30 volts. Make sure your charger can take 30 volts input. Some older chargers like LiPo things, they can't handle that kind of voltage. So one or two things will happen. You'll burn your charger, or it just won't work. It'll give you an error. So one of the two. So that's important to keep in mind. Then I'm going to talk very briefly about battery life. When you charge, and Bobby already kind of covered this over the battery segment, but when you charge at home, I don't care if you have 1,000. With this setup, I can pump ridiculous amounts of current into a 6S pack. I would not do that when I'm at home. I would just charge at 1C. Why? Because I want my batteries to last me a long time. If I start abusing the batteries and charging at several C's all the time, I'm just simply going to degrade the life of the pack. So when I'm at the field, I charge really, really fast, 2, 3, 4, 5C. When I'm at home, I charge at 1C always. That's just something important to keep in mind. And then the balancing while charging. Always try to balance while you charge. And like I said before, you look for a high-powered balancing circuitry on your charger. At the same time, you want to make sure that you have, to begin with, a balancing circuitry. On this charger, for example, you balance through this port on the side, and you can buy boards that plug into that and convert from JST type balancing to TP type balancing connectors and so forth. Make sure, even without even taking into consideration the balancing circuitry power, take into account that you have to balance every time you charge. Just don't ever charge without balancing. We used to do that 8 years ago and it was fine, but now these days with the availability of these connectors, balancing boards, and all these things, and the fact that a lot of these balance plugs have been standardized. There's really only 3 types. There's a Hyperion type, a JST type, and a Thunder power type. There's no reason not to balance. Just make sure you get the right board or the right adapter for your charger that you need for the battery you're using, so you can balance every time you charge. So I think that covers everything for chargers. The last thing I want to talk very briefly about is balancing charging in series versus in parallel. Series charging is not recommended. I really don't recommend it anymore. We used to charge in series back in the day because we didn't have things like these. Nowadays we have these nice and neat parallel charging boards. This one here is made by a company called EP Buddy. It's a really great product. It's like $20. I think I have one. There's another one here made by a different company, I believe. This one's made by, it just says parallel charge board, is made by RC Axis or whatever. As you can see, it's a $20 board. You can buy it with JST balancing plugs, or the Hyperion type, or the TP type. You can buy them with EC5 connectors, or Dean's connectors, or EC3s, you name it. When you use these, you can plug multiple batteries and charge them all at the same time. That works very, very well. The only instance when I generally don't recommend doing that is when you want to charge at a very high C rate, a very high rate. When you charge in parallel, please just as common sense. Just don't exceed the 1C rating. So if you have 5,000 milliamp packs and you're going to charge 2, don't charge at more than 10 amps. That's 5,000 times 2. So 5 amps times 2, 10 amps. You don't want to do that because sometimes one battery might be lower than the other and you'll run into problems. The charger, usually the cells equal themselves out during the charging process, but the charger has no way to tell which battery is lower than which because everything's going in parallel. So just charge at a normal rate, nothing too high, and you'll be fine. So I think that kind of covers a little bit for chargers. And if you want one of these boxes, just hit this buddy of ours, Jay, on HeliFreak, and he'll be happy to make a case for you. If not, just buy a power supply, plug it in, just use your car. I don't care. Car battery works.
All right, and welcome everybody to our connector segment. Because you can't see my face, I shall be a little bit of a hand model today. It's kind of like a finless thing. Connectors! First, that we're doing with connectors. We're going to start from the bottom up. Smallest connectors to the biggest connectors. We're not going to give any sort of ratings. You can look at the manufacturer's recommendations for the amp ratings and you can see what they recommend. We're just going to talk about what we use them for. So first, the smallest one that we could find is the Micro Deans. I hate these plugs. I know a guy who burnt up a research laboratory because he used these plugs. They're stupid. Why are they stupid? Because it's the same for the connector side and for the battery side. It's one plug going in this way. Now they engage great. They don't engage great. They've got two little tabs for you to solder onto. But the problem is, if you've got, especially like we were working with a UAV airplane that had 4 packs that you plug in. So you have all these wires and you start plugging them in and you don't know if one side's a battery and one side's a speed controller. So next thing you know, you're plugging 2 batteries into each other and it's just really bad. But anyway, these things are very powerful. I know that they can handle a lot of amps for their size. So that's a Micro Deans. I'd recommend these, maybe for like a night fly setup if you're plugging your tail into your canopy or something where it's not going to catch on fire if you mess it up. So that's a Micro Deans right there. Next, moving up, is something that I'm sure you guys have all seen. This is just a servo plug. Most people call this a servo plug. Futaba calls it a J plug. Spectrum calls it a servo plug. Okay, so anyway, it's just 3 wires, usually always black, red, and then either sort of like a yellow or this is like a peach color, or most commonly white. So this is a servo plug. So you've got 2 ends. You've got this end, which normally comes out of a servo, and you've got this sort of end, which is like some sort of connector end. This is pretty much equivalent to what your receiver would be. These are great. These are really nice all-around plugs. We mainly use these for like a receiver voltage at most. So if I want to power up my 600 Nitro and just run a receiver pack straight to my receiver, I'll use this plug coming right out of a battery. They work well, they tend to stay connected very well, then they can handle some current too. Now these wires, I'm not too sure how detailed you can see them. These are relatively thick wires in comparison to the size. I want to say this is like a 20 gauge wire. Not exactly sure, but I think that's the most they can cram into one of these plugs. But they're very nice. The only thing with these things is if you tug on them a little bit, they will come apart relatively easily. So what I do when I do these, you can buy there's a yellow clip made by, what's it called? Like HI Model Products or something. That Tower Hobby sells them, I know. It's a yellow clip that fits on it. There's other clips where you can swoop them through the wires. But if you're cheap like we are and just want to use something at the field, just use this 3M exterior tape. It works great. Cut off a little piece and just stick it here. And then when you try to pull it apart, it won't pull apart. So this is the servo connector. Great all-around sort of connector. Next, we've got one that's very similar. This is called a JST connector. You've got your male and your female side. These are great. This has a 20 gauge wire coming out of it. Very good. These are perfect for like a 250 size, 200 size helicopter. I'd say 3S at most. 3S only if you're running like a 800 or 300, 500 milliamp pack. Maybe 800 to 1000 at most. As soon as you start pushing too many amps through these, they just get hot and just stop working. But these are nice, they engage very well. They're really hard to pull apart. These are great connectors. I really liked using these for night flying and just small sort of things like that. They're really, really good here. Next is probably the most common connector ever known to man, and I wish I was the guy who invented this because he's probably sitting on his yacht laughing at us all buying his connectors. This is the Deans. They are made by Deans. I don't know. It's just the Deans. I think his last name is Dean. This is the genuine Deans out there. They're very, very, very nice connectors. Lots of power. I mean, you've got guys powering 700 size electrics with this little connector. This one, as you can see here, Bert has soldered to his Spectrum AR7100R. These Deans are so awesome because they're so versatile. You can use them as a receiver pack, a main pack, fuel pump pack, a starter pack. Align even has this built into their Align starter. They're just so popular. Now this is the legit Deans. The legit Deans really plugs in nicely. They're pretty tough to pull apart. You've got your nice 2 tabs for soldering. This is the legit one. Now there's a lot of cheap Chinese copies where it's kind of like made out of like a harder plastic. It's a little bit darker of a color, I believe. They don't work very well. I've had them actually have intermittent connections and stuff. So I don't mind paying the $5 for 4 when I buy these Dean connectors. I think they're really nice connectors. Just make sure you buy the legit ones. Don't buy the rip-offs. There's just no point in that. Now, the only reason Bert and I don't really like to run these in our 700 electrics is because of them just pulling apart. I'm pretty sure that the Deans and what we're going to show you, the EC5 connector, our next favorite, I'm pretty sure they have kind of roughly the same sort of amp ratings depending what kind of connector you get. But the biggest thing for me that got me away from this as my main flight pack on my batteries is just pulling apart. I just had them pull apart too many times in the air. Now, I believe some people make a connector to keep these together, but for the most part, you know, use these up to maybe like a 6S sort of deal on like a 500 or 550. But for a big pack, we recommend the EC5. This thing is great. This is made by E-Flight. E-Flight sells these. They're beginning to ship, you know, we're seeing a trend now where the companies are actually including these in their batteries as a, you know, as a standard plug. The beauty of these, as you can see here in the package, so E-Flight makes it, the beauty of these is that it's actually a bullet connector. It's a bullet connector that you solder on, and then you just simply stick the connector onto it. Now this is 2 really good things about this. Number 1, bullet connector. This is probably the most amount of current you can get out of a connector this size. Very, very, very efficient. When you plug them in and they spark, they don't degrade over time. It's very nice. And the beauty of the connector is it does not allow you to plug it in backwards. If it was me running bullet connectors, guaranteed I would blow up my car, my house, my family, myself because of bullet connectors. I'm in a hurry plugging stuff together during demos and whatnot. I want a connector that's dummy proof. That's why Bert and I love these things. And when you plug it in, it's very hard to pull apart. The EC5s really stay together quite nicely. Soldering them is a little tricky. You'll kind of get the hint at it, but that's an EC5. We'll put in an intermediate one real quick. This is called an EC3. This is also by E-Flight. These are used kind of similar in a similar league to like a Dean's plug. I don't really like these because I like the soldering of these, but they're very, very hard to pull apart. And especially some of the wire gauges that you go to plug into these, they can become brittle, and I've seen a lot of snapped wires coming off these EC3 connectors. But they're very good, very high current. I would use it very similar to like a Dean's. Very lastly, bullet connectors. These, I believe, are some of the best around. These are made by Castle. They do make bullet connectors. Very good. This is a 5.5 millimeter. They make a 6 or 6.5 millimeter as well. These are perfect for like for putting on your motors. As you can see here, we've got a a quantum motor. These use just a regular included 4mm bullet. That's about the smallest we'd recommend on like a big 700 class motor. But you can use anywhere from a 4mm bullet to a 6mm bullet. There's even guys using bullets, just straight up bullets as their batteries. They work, but you have to be very careful and very adamant not to plug in the wrong thing. So that's our overview of connectors. There's a lot to choose from. Do your homework, see what guys at the field recommend, see what kind of packs you can share. That's our setup on connectors, so yippee.
Okay guys, for this next segment we're going to talk about soldering, and it's really not a very hard thing to do, but for all of you guys that are sort of newbies into electric stuff and never soldered, like I went to college almost 20 years ago, and you know, I came out of college and even though I did a little bit of work with electricity, I really never learned to solder. So I had to relearn all this stuff about 8-9 years ago when I started doing the hobby and getting more into electrics. First of all, make sure you have a good soldering station. This thing is old and beat up, and it's not the most expensive one you can get, but it's actually really nice. It's made by Weller. Weller is a very well-known soldering equipment manufacturer. They've been around for years. They make all kinds of soldering stations. This is the cheapest you can get from them. It goes anywhere between, I don't know, $40 and $60 depending on where you're buying it from. This one I think got acquired here at the local hobby shop, Graves RC. They have much better units, like digital units and so forth, that work much better, but this will do the job for what you want here. So make sure you have a good soldering station, good powerful soldering station. You can go to Walmart and buy one of those soldering guns that are basically this, plugs into the wall. They usually don't have temperature control. They don't work very well. I wouldn't even go there unless you're just soldering something very small. But if you're getting into large electrics and you're more serious about your electric models, get a good soldering station. Make sure you're using a good tip. The tip cannot be too small, but it shouldn't be too big. This is a pretty good size tip. It'll work for small connectors as well as big connectors. If you have to solder tiny little stuff, you might need to get a smaller tip, but this does the job for most of the normal day-to-day applications and stuff like that. Next, get a good solder. You definitely want a resin core, high-grade sort of solder to solder all your stuff. I prefer the thin stuff. Bobby uses the thick stuff. I have some thick stuff right here as well. I like the thin stuff because I have more control over how much solder I'm applying to the wire. It just makes it a little bit easier to not get too carried away with too much solder. Remember, too much solder is not good. You have to use the right amount. So as long as the solder is the resin core, that's the most important thing. You'll be good to go. So make sure you have that. And then last but not least, you want some flux. Even though you really don't need it all the time, it's good to have it. Some of the solder that you can get nowadays have some sort of degree of flux in it, I believe. I don't use flux all the time, but it does help to have flux. Aside from that, you need some sort of jig or something to hold the item you're going to solder. The jig's up is pretty cool. I just bought this again from the local hobby shop. It is very useful when soldering Dean's connectors. You take your Dean's and clamp it here, or when soldering bullets or EC5s or EC3s, because you just stick your bullet like right there. You find the best hole, you stick it in. So it helps tremendously when it comes to holding the item. You need to make sure that you're holding the item correctly. That's very important. Otherwise it'll move on you and you lose the grip on the solder, and the solder will just come out of it, and it'll be a disaster. So sure, have a good jig. You need like a set of ghetto pliers. It always helps. I'll explain why, especially when you're soldering the EC5s. I call them ghetto pliers. I don't know where you can get them from, but they're pretty flat. They don't have a lot of teeth in them, so they don't damage wire when you grab the wire. Some tweezers, some people call them hemostats or whatever. They work. And some cutters. And these cutters are actually pretty sharp. Some people prefer to use an X-Acto knife over the cutters. I prefer the cutters. I'll show you why. Just make sure that you don't cut screws and stupid stuff with them and zip ties, because you'll end up losing some of the sharpness on the blade. You know, I have a set that I use to cut stuff with, and then I have a good set that I only use for wires. So to solder, the first thing we got to do is we're going to take, this is like a really thick piece of wire. This is 10 gauge. Very, very hard to solder because it's very thick. It's going to take a while to solder. First thing is you take your cutters and you just splice a little bit of the wire Just make sure you just cut the shielding and not the wire itself, and you end up with that. Then you find a way to hold that wire somewhere. I'm going to use the jig, even though this is not really the best way to do it. You can use vice grips or anything else. You just make sure that you can hold this in place. And to give you a quick detour here, there's also this contraption right here that you can buy that you can use to hold stuff like wires and things of that nature. For example, like, let's use this instead of the jigs up. Let's use the proper tool. So I'm going to take my wire and I'm going to put it right here. I'm going to change this a little bit.
Helping hands.
Helping hands, that's what they're called. Then you take your soldering gun or iron or whatever you want to call it, and make sure your tip is clean. These things usually have a sponge that goes right there. So you can see I don't have the sponge anymore. So you can use anything, piece of paper towel, just wet it a little bit. Make sure your tip is very clean. You don't want a lot of stuff on the tip. You want to make sure it's clean. Next thing you do is you can do the flux in one or two ways. You can just take the tip and just put it in the flux. That helps a lot. Or you can take the wire and just soak the wire in the flux a little bit. And then once you're done with that, then you take your solder, and what you're going to do is you're going to put the tip under the wire, right under it, and leave it there just for a second and allow that wire to get hot. The wire has to get really hot. What we're doing here is called pre-tinning the wire. The wire has to be tinned in order for it to solder better. So what I usually do is I put a little bit of solder on the tip and then I hold the tip to the wire. Putting a little bit of solder just heats up the wire quicker. And you want the wire to just get really hot. And the goal here is just to apply solder to the top of the wire. When the wire is hot enough, you'll see that the solder starts to get absorbed by the wire. And again, this process can take a little bit of time. So bear with us here while we do this. It'll eventually go, and you'll see how the wire is going to start wicking in the solder, and it's going to get saturated with solder. If you overdo this, if you use too much solder, as you can see, there it goes. You can actually see it now. See how the wire is absorbing all that solder right now, and it's just going all the way in. And you got to do it enough to tin it, but you can't overdo it. If you overdo it, you're going to end up with a big bubble, I guess you could call it, of a big drip or a bubble of solder under the wire, and it's just going to drip and make a mess, and it's not going to help you. That is pretty good right there. That's a pretty good pre-tinned wire. Then for the first solder here, we're going to use a Dean's connector, and we're going to use a female Dean's. So depending on your application and what you're doing, you might want to put a piece of heat shrink ahead of time. Say, for example, if you're soldering a speed controller and you don't have a way to put the heat shrink in after you've soldered, make sure you stick that heat shrink in. I've done that many times by mistake, where I solder the wire and I'm like, oh crap, I forgot to put the heat shrink, and then I have to take the solder joint apart to put the heat shrink to solder again to be able to use the heat shrink. So make sure you do that. Then you take, in this case, we're going to use a Dean's connector. We're going to do a similar procedure, only that this time we're going to clean our tip again, and we're going to use flux a little bit. And then this time we're going to put the tip on top of the Dean's, and we're going to put the solder right on top of it. And the Dean's will get hot, and you'll see a little bit of solder like forming on top of that connector, right about there. That's it. That's all you want to do. Now, one important thing to keep in mind here is the soldering gun's temperature. The welder has a temperature adjustment because I'm soldering a very heavy gauge wire. This is a 10 gauge. I'm setting it to the max. However, if you're soldering like a thinner gauge, even especially like a small gauge, like a 20 gauge wire, be very careful. Start at a low temperature. If you use too much temperature, you're going to actually melt the shielding on the wire. You're going to make a mess, and the wire is going to get actually brittle, and it'll probably eventually break. So next step here is we're going to hold the wire with either the tweezers or the ghetto pliers, and then we're going to put the wire on top of the Dean's, and then we're going to hold it and push down a little bit on it, and the solder that's already on the wire and on the Dean's connector is going to create a nice solder joint. You'll see it actually when everything gets really hot. The solder will get very liquidy, and that's where you want to be at. If you overdo it, you're going to make a mess. If you don't do it well enough, you're not going to have a good solder joint. When do you know that you have a good solder joint? This solder joint right here is not as good as I'd like it to be because I didn't use as much solder. But you know you have a good solder joint when the whole solder gets really, really hot. It has to get hot. You have to see that solder has to become like water, very, very liquidy. And you have to be able to see when that solder changes its state from a liquid to a solid. When you see that sort of transformation occur, you have a good solder joint. If the solder doesn't get hot enough, it gets kind of pasty, kind of in between, more of like a harder, I guess you could say, state. It's not really very watery. You might not have a really hot solder joint. You might have what we call a cold solder joint. And even though the joint will hold, what happens is, guess what? You go fly, you think everything's fine. You get 5 flights, 7 flights, 12 flights. All of a sudden, your thing quits and you crash. Why? Because you had a cold solder joint. So make sure that thing is hot. Now the next thing we're going to do here before we wrap this up is we're going to solder a EC5. I have a lot of people that tell me, why do you fly those connectors? Those things are a pain in the butt. They're hard to solder, yada yada. No, they're not. You just got to be careful. The whole trick here is when you solder this bullet, whether it is the male or the female, you don't want to get absolutely any solder on the outside of the bullet, like in this area. No solder whatsoever, because if you do, then when you try to stick it into the plastic, it won't click in place very easily, and it won't rotate inside this. Ideally, you want this to turn once it's in. So what we do with this, similar procedure, we're going to use the jigsaw this time. We're going to clip our tip, clean our tip again, use a little bit of flux. And you know, in some cases, you can actually do even more than that. Like for example, like I'm going to take, I don't have anything handy that I could use, but I'm going to take, for example, the scissors, and I'm going to put a little bit of flux in the scissors, and I'm going to just stick the flux right inside that connector, just like that. And that'll help tremendously. So what we do here is we take, first thing we do is we pretend the wire again, but we haven't gotten there yet. So we're going to go ahead and cut a little piece of wire on the other side, just like we did before. When soldering the EC5, make sure you don't have a lot of wire exposed here, because if you do, when you actually stick it in, you're going to have a lot of wire coming out of the connector. You want just the shielding to come out of the connector. I'm going to go ahead and do this very quickly here and pretend this. And once we pretend this wire, we'll go ahead and solder the EC5. So now that I have this pretend, the next step, you're going to get your wire ready. And I'm going to take my ghetto pliers. And I'm going to hold on to that wire and have that wire ready to go. It's going to sit right here. I'm going to clean my tip again real quick. And now I'm going to go ahead and start applying solder to the inside of this bullet. Again, you have to be very careful. I'm going to stick this inside the bullet. I'm going to start applying solder. If you use too much solder, guess what's going to happen? It's going to overflow, and then you're done. You're screwed at that point. It's over. As you can see, there's bubbles and crazy stuff. It looks like it's just like boiling, and that's the effects of the flux doing its work. So that's really good. That's what you want. So after that, you're done with this right here, you hold it. Then you go back to your original wire. You hold the wire right next to the top of the tip. I know that's not ideal, but you want to get that wire hot again, or you want to get it to the point where it's getting hot. And once you start seeing that wire getting hot, then you very quickly go like this, and you stick the wire in, and you hold it, hold it, hold it, hold it, hold it, and you just make sure you wait enough, because that thing was so hot that it's going to take a few seconds to cool off and create a good solder joint. And that's about it. When you're done with that, you have a perfect solder between your wire and your EC5 bullet. As you can see, there's a little bit of a gap between the shielding and the bullet itself, the connector itself. That's why I said it's very important that you clip the wire. You just have enough wire exposed to go inside there and keep the shielding covering everything. But this is not bad. This is actually pretty good. Last but not least, when you stick this into this, obviously, let's say that this is positive. We're going to go to the positive side. I already pre-cut a piece of, this is from the cardboard from the top of the actual EC5 package. And I use this so that I don't screw up the wire when I push it down. So I just hold this like that, take my ghetto pliers to grab this. And then This is going to go into the positive side. You just have to press down firmly. You'll hear a pop if it works. There it is. Perfect. This should turn like that. That's how it should work. If it's not turning like this, you made a mistake. What kind of mistake? You put too much solder on the connector and it overflowed, and you have solder residue all around this connector, and then now it won't turn. Is that bad? No. Will it work? Yes. Just pull on it, make sure it's not going to come out. You'll be fine. The only reason why I emphasize on this having to turn or being better if it turns is because when you put this on the helicopter, if stuff is moving around and the bullet is turning inside the plastic connector, you're going to stress your wire shielding less. If this doesn't turn, then your shielding takes a beating over hundreds of flights. Your shielding might get screwed up, or the shielding might start to come off or whatever. But as long as the solder joint is good, this is not coming out of the connector, you're in good shape. Again, if this is not turning, the only reason why it's not turning is because when you started soldering, you used too much solder and the solder overflowed around the connector, and then it just created, changed the thickness on the connector. So that's why it's just not turning freely. So I think that covers it for soldering tips for episode number 3 of Electrics.
And finally, we're going to bring to you a small segment on gearing. Now, I'm not talking about gears and helical and straight cut and all that, because Bert and I have already argued about that, and I think Ray Chicken Wing won that argument. But when it comes to gearing, what I'm going to talk about is physically what kind of gear ratio you're running and how you're delivering power through your whole system, because it really affects everything. Now, a few years ago when we were all running fixed endpoints, the gearing really didn't matter. We just kind of got a motor with a rough pinion and then with the main gear, and worked out a rough gear ratio, and we would just kind of turn the head speed up and down on the throttle curve, and we would get kind of the head speed that we wanted. Now, you wouldn't want to run a straight throttle curve of 40%, because you're holding so much back through your speed controller that you're losing efficiency, and you're getting hotter temperatures and stuff. But recently, we had to be a little bit more adamant about it back then, I guess we could say, because you wanted to be in that 80% range or so. But recently, with the speed controllers having governor mode, I think we've forgotten about it. So let's have a little refresher in gearing, how that works. So gearing, how it works is you've got your motor spinning a pinion, and pinions range in size, usually on like a 700 class model, from I'd say 10 to 14 teeth. Anywhere in there is happy. And then you've got your main gear, which can be anywhere from 90 teeth to 130, depending on the module and whatever. So the goal is to get the most amount of power for the coolest running and the most amount of efficiency. Well, how do we handle that? So let's look at a 700 class helicopter, for example. So for instance, Bert and I are both running motors that range in kV anywhere from 500 to 530. Now, in order to get a gear ratio that gives us the head speed that we want, we run somewhere in like 9.6 to 1 up to 10 0 to 1. So anywhere in there is going to give us a really good head speed, and using our governor modes allows us to get it. Now, for those of you using Castle Creation speed controllers, you've seen in the Castles that you click the little set RPM button, and then you tell it your head speed, you tell it the pole count, you tell it the motor gear ratio and all that, and it figures out a head speed and it says, hey, you're at 96% of your total power. Well, it's not quite exactly right with how Bert and I are seeing things today. They base all their math on 3.7 volts per cell. If you look at most of these batteries, even the cheapies, they're holding 3.94 volts per cell for most of the flight time until it dies at the end. So when it tells you that 95%, it's holding back so much power, it's kind of getting inefficient. So you can turn that number up to 105, 110% on the governor mode, and it's maybe not quite 110, a little above 100, and it's totally fine. It'll give you a red error, but that's kind of where Bert and I would run them, and they seem to work better, and it would get you your head speed where you want it to be. Now, if you look at a controller like Castle versus a controller like a Contronics HeliJive, a HeliJive, if you take the same exact motor and gearing and you put a HeliJive on versus a Castle, the HeliJive has so much more throughput that your head speed with a Castle, for instance, let's say if you were 100% would give you 2100, the HeliJive will give you 2350, simply because of how it's set up. So it's just a bunch of different things to keep in mind. You've got to work your gearing the correct way for your speed controller and for your motor. Now, how do you change gearing? On most helicopters, you just change the pinion. The pinion's the easiest. Some you can change a main gear, but that's not really practical. Other helicopters like the Goblin and I'm not sure if there's maybe the Caliber or something, they use belt drives. You change the pulleys and whatnot, and you can change your gear ratio that way. What are the benefits of having different gear ratios? Recently, I'm preferring like a 10-to-1 sort of gear ratio on an electric 700 size rather than a real aggressive gear ratio. Everything runs cooler. I get a little bit longer of a flight time. And it's just easier on everything. It's not as powerful, I'll say, versus like a 9-to-1 gear ratio, but I'm not holding my speed controller back. My speed controller is almost wide open. My motor's running cool. I don't have that instantaneous, like, I almost want to say like a low torque, really like that grunt, but just for big flying and everything, it really runs well. So for gearing, just take a little bit of a look into it. You know, with the cavias of the motors and the different pinions and whatnot, you can get the gearing that you want. But just be adamant about it, and now you know a little bit more about how to gear up your helicopter. Thank you all for watching Large Electrics Part 3, number 25.
Number 25.
I learned a lot.
I didn't learn anything this time.
I did.
But it's still, I'm sure a few of you guys probably learn a thing or two. So
I always learn something.
that's what matters.
And if you guys are just waking up because the episode was that boring, at least you're here in time for the credits.
Exactly. So
That's what
we're
we
gonna
aim for.
let's get out of here. We have
the
the
hell outta
Smack Mobile here.
That was like a serious intro, kind of like what we know what we're doing.
Or the shielding on the wire. If this doesn't turn, then you're gonna be pulling. See, that's my great solder job.
Are you shitting me? So it's Saturday night. We finished filming the episode recently, and Bert got a new car. It's a new Beamer. It's an M3. So Bert got an M3, and we want to take Doc Wing for a ride, but he's scared shitless. So we're in the car with Smitty. You'll remember Smitty from episode 6, because Smitty's the man. And we're gonna film Ray, and he's gonna shit himself. So here we go.
To give you better handling.
You excited, Ray?
Oh yeah! That's awesome. Fucking gonna kill him.
All right, here we go.
He's gonna shit himself.
Oh shit! I can't do that. Oh shit! Oh my god! I'm gonna kill you! I'm gonna kill him! Holy shit!
We're doing 80 on a 35.
Oh fuck! Oh shit! Nice! Nice!
She holds good, Bert.
You're fucked up in
She
here!
holds all the curves and everything.
Oh yeah, it's fucking thrilling! You fucking asshole! I hope
So,
your dick
all right,
don't
we're good. We're good.
Ray, why are you so
Ray,
pissed?
slow down.
fucking hell, you gotta be shitting me!
That was a good
You know
exercise,
what?
Ray, wasn't it?
I hope when you go home tonight, your dick don't get hard, so you can't fuck Susie. Fuck
Okay,
you.
so-
A little looser in that mode then.
Oh, it's very loose.
Yeah.
My will is on my desk.
Oh yeah. You can feel the difference.
I'm gonna kill him. I'm gonna kill him.
Definitely.
Fucking kill him.
We're at 100 already.
Ray, we went 100.
Now watch the stopping power. Just get a
fuck.
really good grip on yourself.
Do it.
Watch how it stops,
it.
dude.
Let's
This is
do it.
this is BMW's stopping power.
I'm gonna kill him.
With 800 pounds. Son of a... Yeah, she stopped quick, dude.
Get me the fuck out of here. You fucking asshole.
Demo time's over.
That was like a...
How you like that, Ray?
Did you shit yourself, Ray?
I think I pissed that shit. I know I got some fucking
I
turtle coming
appreciate
out.
you getting on the car. It shows that the wing is brave.
Yeah, the wing is brave.
The wing is brave.
The wing's got a turtle coming out.
Turtle head popping out.